welcome to another episode of That's Absurd. Please elaborate, the hopefully comedy and hopefully science podcast where we take absurd, outlandish, weird, ridiculous questions from you, the listener, or each other, and we do our best to apply our years of rigorous scientific Googling skills that we've accumulated to find a real answer for it. I am one of your two regular hosts, Julian Huguet, and the other one of two, the thing that makes it whole, Trace Dominguez, he's in the middle of a move right now. So we have a gracious guest host stepping in for him. You may know her if you are a longtime fan of the show. She's literally the first guest we ever had. She's the host, comedian, producer, apparent filmmaker, Sophie of Science with Sophie. Welcome back, Sophie Shrand.
What a pleasure. I was going to introduce myself as Trace Dominguez, but I guess cat's out of the bag.
That would have been so good.
I'll do it later. Maybe I'll try it anyway.
You have to be like overwhelmingly positive and friendly.
Well, that's why Trace and I were immediate best friends when we did a show together. And I think some of the comments we got from that show were people being like, science is fine, but those hosts are really energetic.
They're like a lot. Prepare for a lot today, audience. I think, Sophie, from what I know, you haven't shared your actual answer with me yet, but you were giving me updates on the research that you were doing. And you were like, hold on, I found more. And I'm really excited to get into it. So let's start off. Sophie, what is your question and from whom did it come?
This question was submitted by Hillary. And fun fact, she asked this question on my birthday, which I didn't even know until I looked at the notes.
Cool.
So
that's,
yeah,
which is, when you can't just say on my birthday and then let it go. I have to know so I can remember for later.
June 13th.
Oh, wow. You just passed not too long ago at time of recording. Okay. Gotcha. Happy birthday. Okay.
Thank you.
What was Hillary's birthday present to you?
Hillary, knowing it was my birthday, asked me a question that she knew I would love, which is, do animals other than humans hiccup? Yeah. And there's a note attached to it as well.
Okay.
Which
she
I really liked.
Adds more context. What's Hillary say?
So Hillary says, I was gardening next to my chicken coop and one of the hens made a noise that sounded exactly like a hiccup. She didn't do it again, so it was likely just a weird chicken sound, but it made me wonder, do chickens hiccup? So not only do other animals, but chickens specifically.
So yeah, that's you have to hone in. If it does happen, you have to narrow it down eventually to chickens if you can. These questions have been coming up semi-regularly. We got asked recently if like other animals sleepwalk, and I thought that was going to be really easy to figure out, and it really wasn't. So take me on a journey. What did you discover?
I am so excited to take you on this wild ride. There are a couple things we need to dive into before we can get to the real heart of this chicken hiccup question, this Chickup question.
Okay. Chickup. That sounds like a dating app.
You know what? I would download it. I'm married, but I would just check it out.
Okay. Yes, I also would hypothetically download it.
Mainly because I want to match up chickens with other chickens. I assume that's what it is.
That's what it is. It's not you matching up with other people. It's like finding hot chicks in your area to pair, like literal chicks to pair with them.
And it's LA, so they're like all sweaty and hot, and you're like, hot. Yeah.
Yeah, they're out on Runyon Canyon, like, oh, you're like in full makeup. Come on, you didn't roll out of bed and go hiking like this.
Nobody does.
Come on.
You gotta bring a towel. Okay, so here's what we need to do to answer this question of chickens hiccuping or not. First, we need to define what is a hiccup. Then we need to get into who hiccups. And after that, if you're game, I want to go into why hiccups. Why at all?
Oh, I'm game like a chicken. Let's go.
Let's go. Okay. So first of all, what is a hiccup?
Are you asking me?
Oh, do you know?
I have an idea.
Okay. What do you think a hiccup is, Julian?
So you got the two pipes in your neck, right? I think I'm being technical when I say you got the two pipes, right? You got the esophagus and you got the larynx, right? Mm-hmm. And the esophagus is the food one, right? And the larynx is in front of that, and it's the wind one. And in order for the wind one to work, it's very important that the food meant for the food one doesn't go into the wind one. And so there's like a little flap that covers up the windpipe. And I think a hiccup is something, I don't know how, I don't know why, but something makes the little flap go, and and then you hiccup. Just like the flap just goes rogue.
Yeah.
And is even though there's no food, it's like, I'm gonna do my job here, and then it hiccups you. Am I close?
You are very close. First of all, 2 tubes, absolutely right. We got those 2 scientific terms. We got your food tube, we got your air tube, absolutely. The pipes. We got the pipes. We got the food pipes.
It's a series of tubes. Okay, yeah.
It is. We're just a series of tubes. Our bodies are entirely tubes. 100% tubes.
We're tube-based life forms.
We are tube-based. That's our class. There's backboned animals, and then under that, we're in the tube category.
What is a backbone but a nerve tube?
Right.
You know?
Exactly.
Yeah. It's all tubes. Tubes all the way down.
That's right. And what is a nerve but a pain tube and a pleasure tube and a, you know?
Yeah. Well, pleasure tube is that's another dating site.
Well, we have
Maybe
repetition.
not a dating site.
We have repetition in our bodies.
Okay. Yeah, that's the important bit we're getting at. Okay.
Yeah. So you're really onto something here. So when we hiccup, it is thanks to a number of muscles and how they affect those tubes in our bodies. So we have the sound is produced by the vocal cords and the glottis in that tube, right?
In the wind tube, yeah.
In the wind tube, in the larynx. The cause is further down. It actually is thanks to our diaphragm.
Okay.
Our diaphragm, that thin muscle. Are you familiar with the diaphragm, like a little drum?
I'm a theater person. You know I'm familiar with the diaphragm.
That was a layup. I knew you would. Listen to that beautifully breathed laugh that you just gave, right?
Projection. Yeah.
So good. Yeah. So anyone who's ever taken a theater class or a voice lesson or been a human has used your diaphragm. And so if you think about the diaphragm is a thin sheet of muscle that sits underneath your lungs, between your lungs and your stomach and liver, and it helps you breathe. It's a very critical part of breathing. It expands, and as it expands, what it does is allows your lungs to expand. Also, the rib cage helps with that. But when the diaphragm expands, your lungs expand, and that allows you to take in air. That's your inhale. And then as the diaphragm constricts, so do your lungs, and you exhale. Aren't we so relaxed? It's so nice.
That's nice, actually. I do feel at peace for once.
So many of us never really think about our breath. And one of the things this is a sidebar, but I have a science background and a theater background, as we've discussed. When you take your first theater class and then you learn how to breathe, and everybody just starts crying because it's so emotional to realize we haven't paid attention to our breath, and breathing is so powerful and important and autonomic. So often we aren't really thinking about it. Anyway, that's just, I know, so relaxing. This is now a sleep podcast.
Well, now you've gotten in my head, and now I can't not think about my breathing. It's like when they say, don't think about your tongue, and then all you can think about is where your tongue is in your mouth, and you're like,
that's right.
ah!
Yeah.
Right? Is that that's happening to me now with my breath. But yes, for others, it may relax them totally. Not for me, though.
I tried to do a meditation app
recently. Ball of nerves.
Yep, ball of nerves. I tried to do a meditation app recently, and it was like, we're going to count down from 54. And I was like, 54?
What? Why 54?
Immediately. Not liking it.
I need answers. Why did we pick this arbitrary number?
I was so mad. Anyway, all right. So this is how breathing works. The diaphragm is super important. Normally, we're not even thinking about it. It does this all the time. Sometimes, though, it'll do a little blip. It'll spasm. It will expand really fast. It will twitch. And when it twitches, that means you're intaking that air really fast. And when you intake the air really fast, it closes up those muscles in your throat really fast. 35 milliseconds fast. And that is how we get that sound, the hiccup, which is the onomatopoeia word hiccup.
So it stems from farther down. It's the diaphragm spasming, and it like sucks the little flap, the epiglottis, closed basically for a split second.
Yes.
Interesting.
Yeah. So it's the epiglottis and the glottis, which is the vocal cords are part of the glottis, and that's in the airway. And then above that sits the epiglottis, which is that flap. So
epiglottis literally means above the glottis, so that makes sense.
Exactly right, above the glottis. But the sound that we're hearing is the vocal cords shutting very quickly.
Oh, okay. Okay, interesting. Yep. Very cool. Right. So presumably then, to hiccup as an animal, you need these same parts. You need the tubes and the glottis and the diaphragm. So fish are out. So no fish hiccups.
Well,
wait, no, stop.
Julian.
No.
I'm so glad you said that, because that is the next logical question, right? First of all, who has a diaphragm? Well, all mammals have a diaphragm. So, Julian, it sounds like you already knew that.
Yeah, I guess. I don't know. I don't know anything. Don't assume anything from me. Go on.
Well, okay. So, first, here are 2 fun facts that I want to share about that, and then we'll keep going to who. One is that we can get hiccups before we're born. And that's mammals, right? Humans are mammals. So keep that little nugget in your mind, because we're going to circle back to it.
Okay. All right.
How cool is that?
That is cool.
Pinned. And then the other one is a fun fact that I thought you would get a delight out of, is that the scientific term for a muscle spasm, that kind of muscle spasm that the diaphragm's doing, is called a myoclonic jerk.
That sounds like a cocktail to me. Like, I could see myself going up to a bar and I'll be like, I'll have one myoclonic jerk, please.
And they're like, you're looking at them.
Yeah.
Wait a minute.
What?
Wait, they're really down on themselves. So myoclonic jerk, just put that one in your pocket for your next cocktail party when you're drinking your signature drink. Okay, so do all mammals hiccup? Do all mammals have diaphragms? Julian, what do you think?
You did say yes, they do. So based on the answer that you gave me earlier, I'm going to go with yes.
You have a good memory. That was a memory test.
That was a whole 30 seconds ago and a pass.
Yeah, a fish you are not. So,
doing great.
Mammals are the only class that has a diaphragm, and all mammals have a diaphragm. So only mammals and all mammals, which is also the name of my prog rock band.
Only mammals, all mammals?
Yeah. Only mammals, all mammals.
I kind of love it. Okay.
Right?
Wait, but like mammals, that's a decent sized clade, but it is by no means a large clade. I mean, there's so much. So you're telling me reptiles do not have a diaphragm?
They do not. They do not.
Okay.
So they do not have a diaphragm. Birds do not have a diaphragm. Fish do not have a diaphragm. Amphibians do not have a diaphragm. Only mammals.
You know, I guess I knew that about reptilians, because you want to know a fun fact. We have a pet lizard, Phil. It's a large bearded dragon. And here's the thing that we thought was funny is Phil, during mating season time, or when Phil's having a lot of energy, she'll get up and she'll run like the dickens across the floor, and then she'll just stop dead. And I learned later from an excellent YouTube channel called Clint's Reptiles that the muscles that most lizards use for walking are also the muscles they use for breathing, for expanding their lungs. So they cannot run and breathe at the same time, unless they're like a monitor where like you'll see their throat kind of palpitating, and that's like their throat muscles forcing air in, but most lizards are not like that. So yeah, I guess in the absence of a diaphragm, they've had to find other ways to expand their lungs, and it's like, oh, these are muscles while I'm at it. Like,
yep, exactly. I might as well use these, which personally is how I also feel about running, but that's a different story.
Yeah, I can only run for short bursts, and then I need a long time to recuperate.
Yeah, I can't breathe and run at the same time.
No.
That's a me problem. Maybe I'm a lizard. I don't know. Never thought about it.
Perhaps.
I get cold a lot. I don't know. We'll explore. So there you go. You're absolutely right. So this led me down this path of thinking about how do all these different animals breathe at all, which was really fun to think about. You're absolutely right. Reptiles have lungs, but they don't have diaphragms. So they're using other muscles, they're using their rib cage, etc.
Right.
Now, but hold on. Yes. Before we even get there, we got to backtrack again to the mammal thing, because if all mammals have diaphragms, does that mean that all mammals hiccup?
Ooh, yeah, the diaphragm's an important first step, but by no means the only requirement. So I'm trying to think of mammals that don't have a glottis and vocal cords. I don't know. I don't know enough. I don't know enough animal biology. Okay, tell me.
You're in luck, because I looked it up. So,
oh, perfect.
So it turns out that many different mammals hiccup. It's totally possible, and it's actually quite common in a lot of different mammals, possibly all mammals. We haven't studied all of them, but we've studied rats, cats, rabbits. We've noticed them in horses and dogs, humans, obviously. So many different mammals get the hiccups, which is very cute.
Okay. Yeah, that is cute. Oh, little bunny hiccups or something.
I know, right? Can you imagine?
Oh.
And we get hiccups for a lot of different reasons. Like, what are some reasons that you have experienced hiccups, or things that you think have caused the hiccups?
Getting cartoonishly inebriated.
Okay, yep. Yep, absolutely.
End of list. That's all.
Great.
That's all that comes to mind for me.
Little X's on your eyes, little stars going around your head, and hiccups. Yeah, that's correct. That is the most scientifically common. Other reasons include eating too much or eating too fast. put a pin in that one because we're going to come back to it too.
Okay, I've got 2 pins in. Okay.
2 pins, great.
Yeah.
Getting scared or like laughing too much. There's no such thing. But like all these different reasons or sometimes no reason at all, right? It just happens. So a little bit of a mystery there, again, that we'll come back to.
Okay.
Lots of different mammals hiccup. But Hillary was not asking about mammals. She was asking about chickens.
She did, in fact, ask about chickens.
Mm-hmm. And mammals are just we're just one little class of chordata.
Yeah.
You know?
Yeah, there's a whole lot of vertebrates out there.
Whole lot. And we need to include them in this search. Which brings us to how they all breathe. Because if they don't have diaphragms, which they don't, then technically we could stop here and say the answer is no.
Mm-hmm. Mm-hmm.
No. Technically not a true hiccup if you don't have a diaphragm, because the way we've defined a hiccup includes a diaphragm.
This comes from the diaphragm.
That's
okay.
Right. Yes.
Gotcha. But I happen to know a little bit about this. Bird lungs are special.
They are special.
Aren't they?
They are so special because they only go in one direction.
Yeah. That's bananas. That unlike ours that are like in and out, that it's a one-way trip of gases through bird lungs, and it's so freaking cool.
So cool. It's the most efficient in the animal kingdom. And it's what allows them to fly, essentially, because they're able to get enough oxygen to power flight, even in high altitudes where there's lower oxygen in the atmosphere. Right.
Unlike us, where because of that, the method that we breathe, we've got like big dead areas in our lungs where no air comes in or out because it's just a flaw in the design, you might say, if you cared about efficiency that much. But it works well enough for us.
Willy Wonka's chocolate factory. Nothing in, nothing out.
Full of tiny orange men.
Those are the little alveoli that are all just...
Yeah, my x-ray comes back and they're like, oh my gosh, your Oompa Loompas are looking terrible lately.
Yep.
Sorry, alveoli. I'm sorry, it's my first day as a doctor.
Oh, did you see that? Yes. I just got here, actually.
You put the stethoscope on and you hear like a little song like, Oompa Doompity Diggity Det, you should not have smoked that cigarette.
That was really good, Julia.
It's really easy to make Oompa Loompa rhymes, as it turns out.
I don't know. Some people might say that's really hard, and you did a great job. Every time you wheeze, it's just a teeny tiny song.
The Oompa Loompas rebelling.
Yeah. They're trying to get out, but they can't.
Okay.
So yes, we have bronchi with alveoli that we've increased our surface area. We have all these little grape-like looking sacs in our lungs. And we're not the only animals that have air sacs. Birds have a bunch of air sacs, but they have them in this completely different configuration. And it is super cool, super efficient. And I highly recommend, if you're listening to this, maybe go look up how birds breathe. It includes their butts a little bit. Yeah, it's so cool. But they do not have a diaphragm.
Right, right.
Yeah.
So no hiccups.
Technically,
now,
no.
That said, you're saying technically a lot. I'm noticing I've been doing SciComm for long enough to know when hedging is happening or when corollaries are coming. So technically, they don't hiccup, but do they do something that is hiccup-like?
No, but some other animals do. Some other animals do, and I think that's where we're leading.
Oh, I really thought that's where we were going with this.
As far as birds go, they can't hiccup, they can't cough, they can't do any of that. So sorry.
So Hillary, there's your answer. No.
The short answer, no. Long answer, hold on to your butts because there's so much more. Okay.
Grab your cloacas, chickens.
And breathe through them.
Hold your butt breath, chicken.
It's time for breath therapy, theatrical chickens. And then we're going to put you together so you can date.
On Chickup.
Sponsored by Chickup.
Sponsored this.
We're doing sponsorships. You've been here for a year and you've made so much progress since the last time I was on. This is so exciting.
I know. Well, we now actually have listeners. Sophie, you predated when anybody was listening. The episode you were on, we hadn't released a single episode yet. So what a fun treat for you to know that people will actually listen to this one.
Yeah, so you're like, you might know her from our podcast, and everyone's like, we don't.
What? No. What? Who? Okay.
All right, so we've covered birds. Birds have this really cool unilateral breathing system, which is amazing. No hiccups. Now, what about reptiles? Reptiles have lungs, but they don't have diaphragms. No hiccups.
Right.
What about fish?
How
do fish breathe, Julian?
They just pass water over their gills.
Exactly right. Yeah. So
Yeah.
they don't even have lungs.
No.
Now, there are a couple exceptions.
They're way out.
They're way out. There are a couple of exceptions. There's lungfish, right? Literally.
Yeah.
But for the most part, fish, just have that passive capillary action, exchanging gases through their gills.
Although I did learn on a recent episode I did with Trace, we talked about the pufferfish. And the pufferfish have that adaptation to puff up, and it stems from an adaptation where they would basically, fish would take in water into their stomach and then cough to like expel something that might be blocking the path into their stomach.
Oh, now that's interesting.
Yeah, not really a hiccup, and there's no sound produced by it, maybe just like but like, you know, a little bit of water moving around. But yeah, it's they don't have lungs per se, but they do take in and then expel like water in a sort of cough, which I think is cool.
That is cool. And they do have a glottis, as do reptiles. The glottis in a reptile, though, is always closed except when breathing. So that's another reason we can negate the idea of hiccups in reptiles, because it's closed by default.
Gotcha.
Yeah, ours is open. So that point that you just made brings me to amphibians. Because amphibians have both gills and lungs. They're water-dwelling and land-dwelling.
Yes.
So what do we think about that?
But do they hiccup? Is that what you're asking me? Because oh man, I don't want to venture on a limb. I'm going to say yes. I'm going to say yes, they do. I'm just going to caution to the wind. Yeah, amphibians totally hiccup. Let's do it.
Is that
right? No, come on, they can't. No. Yes? No, I can't. I don't know how to read you yet. We haven't co-hosted enough times together. I don't know.
We've gone to birthday parties for Trace's child.
That's different.
So birds hiccuping? No. Reptiles hiccuping? No. Fish hiccuping? No. Amphibians hiccuping? Well,
I think no, because they're like in between. They're like an evolutionary kind of branch off of fish, but like before reptiles. And you'd think if there's no hiccuping before and there's no hiccuping after, then there shouldn't be hiccuping with amphibians. There is, isn't there? Isn't there? Is there? Just tell me. I'm dying here.
Here's what gets us into the mystery of hiccups. The mystery of it all. Because we don't know why we hiccup. This is the thing that happens to all humans. And yet we don't know why. It's a scientific mystery, maybe the great scientific mystery of our time, Julian.
This is it. Dark matter, get out of here.
It's fine. It's fine. It's interesting. But
the people need to know.
Literally every single one of us does it. And we have no idea why. But we have hypotheses. And this is where our fish and amphibian friends and ancestors come into play. Okay. So there are some really interesting hypotheses about why we hiccup. One of them is this idea that it's an evolutionary remnant from our fish ancestry. So we evolved over lots and lots and lots of time, way, way, way back, like at least 10 years ago, we were fish bodies. Some of us took longer than others, but...
You're not wrong. At least 10.
At least 10. Yeah, not wrong. At least 10.
At least 10 years ago, human ancestors were fish. Yeah, got it.
Exactly. So the layout of the nerves in our brain that cause breathing, that have to do with breathing, our phrenic nerve and our vagus nerve, they evolved from the fish body. This is the hypothesis, that the way they're laid out in our body evolved from the fish body. So they start in our brain and then they go through our skull and all the way down to the diaphragm.
Right, through the spine tube.
That's right, through that big tube in the middle. Now, in a fish, it would have been much more efficient because the gills are right there next to the brain. Now, for us, it's sort of like elongated and got less efficient because that's how a lot of our evolution worked.
That's just how it goes. When you take something that was meant for one thing and kind of use it for another thing, sometimes it's not pretty, but if it works, it works. Yeah,
it's part of the beauty of it. It just is like, wow, how did this happen? Well, it was over like hundreds of millions of years. And how cool is that? But the trade-off is efficiency, perhaps. So this particular hypothesis, these particular scientists think that it's this convoluted pathway that leads from our brain down to our diaphragm. And this can lead to those sort of blips, those little accidents, just because there's more room for things to just get crosswired and haywired.
Okay.
Yeah. So that can lead to these little misfires and these quirks that then cause the diaphragm to spasm.
So what I'm picturing is my body is like an old rusted out Chevy with some rat chewed wires that connect to my diaphragm and my glottis and everything. And occasionally these bare wires just touch and my diaphragm just spazzes and goes.
Yeah. And that is basically what these particular scientists say the human body is like jerry-rigged from a fish.
Now I am imagine jerry-rigging a fish with duct tape and wiring.
Yeah.
Be like, make it walk on land.
Yeah. There's a book about it. This guy, what is his name? Hold on.
Is it Your Inner Fish?
It might be. I think it might be. Or I think it might be called The Fish Body. We should look it up and then make sure it's accurate in this. But Neil H. Shubin.
Your Inner Fish.
Yeah, Your Inner Fish.
My wife has that book. It's a great book.
There we go. So this is a lot of Neil's work. He's an evolutionary biologist and paleontologist, and this is definitely his argument that we have evolved this from fish and is sort of a vestige of an inefficient system because it was efficient back when we had gills. And then he also goes on to have a second part of this, and this is where amphibians come in.
Okay.
So this is what was so interesting to me and why I was like, Julian, I need more time.
Wait.
Hold on.
I must.
Wait, there's more.
I told you this wouldn't take much of your time to fill in and that you went so above and beyond. Okay, tell me about the amphibians.
Okay, so I'm going to read this quote directly from Neil H. Shubin because he wrote this in Scientific American. He wrote, okay, so the characteristic pattern of muscle and nerve activity of hiccups occurs naturally in tadpoles that use both lungs and gills to breathe. What? Why?
Tell me, Neil.
Okay, so because tadpoles are pumping water into their mouth and throat to pass over the gills when they're in water, because tadpoles live in the water. But in order to prevent that water from getting into their tiny little lungs, they got to do something about that. So...
Oh, they're like us with the tubes.
With the tubes. They're like, I cannot let this water go into my air. They got to
close up that tube.
They got to close up the tube, except instead of like a peanut butter sandwich, it is water that's trying to get them oxygen that they need to live. So they close the glottis while sharply inhaling. What does that sound like?
That sounds like a hiccup.
Now, it's basically one long hiccup.
Oh, poor little tadpoles.
Yeah. Because it doesn't happen as fast as ours. It's not like the way we know a hiccup, but it's the same mechanism.
Fascinating.
Isn't it?
That's so cool. But I do feel sad for the little tadpoles, and you can't do the normal trick where you have to slowly drink a glass of water or something, because that's what they're trying to avoid. That's their whole problem.
That's the whole life.
Wow.
Yeah.
They just have to wait until they turn into frogs.
Yeah, and then they can just breathe through their skin.
Yeah.
Which is pretty cool.
And then they ribbit, which is also feels like a hiccup adjacent, but probably isn't.
There are a lot of different animal sounds that make people think they're hiccups, and they aren't, but they're still noises. They're still cute, and they're still fun. And for some, they can be like indications of other health issues or just parts of their behavior, but they are not a true hiccup. Now back to mammals for a minute, Julian, because remember I had that other pin about babies.
Right. I remember this pin about babies in the womb. This pin number 1, hiccuping. When they're in like a fluid, but they can't take anything into their lungs yet because of the fluid that they're in. So they close the glottis. Is that what's happening?
They're just little tadpoles in there.
Little tadpole.
Okay, did we finally get to the audio peak? Did we peak it? Did we do it?
I think we did. I think we definitely clipped on that. Sorry, Kyle.
Okay. So this brings us to the other hypothesis about why we hiccup. And this one, as you can tell, I'm trying not to be biased. I'm a scientist, but I really like this hypothesis a lot. I think it's very compelling. So we've got our fish evolutionary hypothesis. I think that's interesting. This one focuses on the why of mammals, and this hypothesis, which doesn't have any real evidence yet because they haven't fully studied it, but it suggests that hiccups are a burping reflex for babies, and that we may have evolved to remove air from the stomachs of suckling young mammals. Did I blow your mind? Finally speechless.
Yeah, I'm thinking about the implications.
Imagine you are tiny little baby singing your little Oompa Loompa songs as you get ready to bring your lungs into the world. All right?
Okay.
So when you're a baby, you are guzzling milk. That's what one of the things mammals do is that we drink milk and we guzzle it down because we need a lot of calories and a lot of food to get bigger and stronger and grow up. Okay. When we're guzzling all that milk, I can't stop using the word guzzling here. When it's part of it. When
it's a gross word.
I know,
the more I hear it.
I know.
Okay.
But I'm gonna
when you're just
slurping down the milk slurry,
just chundering it away,
and you're just chugging dairy.
Right? Yeah.
Yeah. You know how babies are like, "Get me all of it!" Like they just cannot.
What's the opposite of ASMR? Because I think we just created it. Do you want to hear a bunch of really unappealing sounds right in your ears, listeners? Anyway.
It's me, your recurring guest, here to give you a bad time.
Sophie, here with some disgusting noises for you. Okay, go on about the milk guzzling.
So, as you're guzzling, all these babies need to drink a lot of milk really, really fast. Now, as they do that, they swallow air because you're just eating so fast. You've scarfed down food before, and then you're like, oop.
Yeah.
And I'm like burping a lot because I just accidentally ate air too, right?
Right.
It's the same idea. So that air gets trapped in your stomach. So this hypothesis suggests that gas bubble triggers the afferent limb of the reflex, meaning that the muscle itself, the diaphragm, is going to send a signal to the nerve in the brainstem, which in turn sends a signal back down to the muscle to twitch. By twitching, the lungs can expand, right? The diaphragm twitches, the lungs expand, and that quick lung expansion drops the pressure in the chest, which allows the air to get pushed from the stomach back up through the esophagus to sort of like part way in the esophagus. And then once the muscles relax again, the air can make its way out. And that leaves more room for milk. You've gotten rid of that air bubble. Now you can fit more milk in your tum-tum.
Okay, that makes sense. I mean, I've never had to breastfeed a child personally. But yeah, don't they get hiccups when they drink a lot of milk? Isn't that a thing?
It is very much a thing. In fact, babies hiccup 2.5% of their life. 2.5% of a baby's life is spent hiccuping.
Wow.
That's a lot of time.
That is a lot. That's a lot of time.
Yeah. And it's a lot of time. They do it a lot. And then as adults, we learn how to regulate how we eat. And so it doesn't happen as often. But when we eat too fast, we are more likely to get hiccups.
Okay. Yeah. Okay. I can see that.
Right. So that's some suggestive. Again, this hasn't been studied yet. And it kind of makes me want to like stop everything and go be a hiccup researcher because I'm like, I gotta know. This seems testable and this seems so interesting. And there's another fun fact that I learned that I thought, okay, this really does seem like an interesting hypothesis.
Okay, I'm on board.
A bunch of studies have shown that only the left side of the diaphragm is involved in hiccups. That's the left.
What?
Yeah,
why?
Yeah, the left hemidiaphragm is the only part involved in these hiccups. Guess what's under the left side?
Your stomach?
Your stomach!
Okay. It does seem like more than a coincidence.
I agree.
Okay. Very cool. Wow, I never thought there was even this much to know about hiccups.
I really went down the most delightful rabbit hole.
You sure did. You sure did. Is that our conclusion? Hillary, no, but also I hope you learned a lot along the way.
Yeah, it's about the journey, not the destination.
Yeah, you think you're going one place and then like there'll be a hiccup.
And then you're like,
I have to learn more.
And then, and then you do learn more and you're like, what the hiccup?
Yeah, just like that.
What? Yeah.
Well, Sophie, that was awesome. That was so much more elaborate and interconnected to like the origins of our species than I thought it was going to be. So I really appreciate that.
My pleasure. Thank you for joining me on this trip.
This winding road down our wind tube, stomach tube, through all the tubes.
Through all the tubes. I just love a mystery.
Yeah.
I love a mystery, you know?
Well, that was awesome. We are going to take a quick break, and when we come back, we'll have my question.
Julian, give me your best dinosaur roar.
Oh God, an asteroid! It's horrible!
Wow, that was not where I expected that to go. We're popping in before the show to tell you about I Know Dino. It's a dinosaur podcast.
You know, we think of those dinosaurs being this thing that's been dead for tens of millions of years. Even so, studying dinosaurs can still teach us stuff that is relevant to the world today.
Yeah, like climate models to help us understand global warming.
Migration patterns of dinosaur lineages, they tell us about Earth's changing continents.
We can also study dinosaur diets, what plants lived then, and maybe what animals and how they interact.
And, this is super cool, many dinosaur injuries, paleopathologies, they're the first known occurrences of diseases.
And they talk about all this kind of stuff on I Know Dino. It comes out every week with new dinosaur stories that you're not going to hear anywhere else. Like, I hadn't heard of a lot of these, which is pretty cool.
You can find I Know Dino on Apple Podcasts, Spotify, wherever podcasts are. And if you found us, you can probably find them. Go check them out.
Welcome back to That's Absurd, Please Elaborate. I'm your guest host this week, Sophie, and I just told you all about hiccups, and now it's time for Julian's question.
So my question comes from Jade. It's another animal-centric question. There's definitely a theme this episode. Jade asks, why don't we seem to see any animals that have evolved wheels?
Oh, this is a great question.
I've had the same thought, and I never dug into it. I kind of had an intuitive sense of why, and I got to check if my ideas were right. But Jade expounds upon this. She says, I can go way faster and way farther on a bicycle than I can on foot because using wheels for transportation is way more efficient. But then if wheels are such an efficient way to get around, surely I feel like it should be more commonplace in nature, right? I realized recently I've never seen an animal with wheels, though I know of some animals that will roll up into a ball and go downhill. Is it just too inconvenient when having to deal with uneven ground? I think that's part of it. I think that's a good observation. I think she teed up something that we'll get to later about wheel-like adaptations. First question I have for you, Sophie, though. In all of the inventions that humankind has invented, where do you put the wheel? Like, top what?
Oh, like top 6 of the 6 simple machines.
Oh, you think so?
I think all the simple machines are great.
That's pretty good. That's pretty good. Although fire, right,
yeah.
I would consider.
Okay.
Well, fire's more of a discovery, isn't it?
That's the thing. Yes. I think it's a lot of hubris to say we invented it. It was around.
Inventing fire. Yeah. Somebody was like, oh, wait, I can use this, you know?
Yeah. And we figured out the tools to be able to make it.
But fire definitely predates us and will be here long after we're gone.
But wheels?
But the wheel, yeah, you could say is a human invention. I would put it in the top 2, personally.
What's the other one?
Levers.
Okay.
This is another simple machine. Actually, originally when I was writing this, I was thinking fire, and now it just dawned on me that I can't say that. I had to scramble and pick another one. Okay, anyway.
Levers are pretty good. I think inclined planes are pretty cool because
wow.
Well, because an inclined plane is also, it's involved in a lever, it's involved in a screw, it's involved in a lot of other simple machines. Just throwing out one for inclined plane.
It's true. It is. But I feel like this inclined plane opinion is going to drive a wedge between us.
Oh, now we're really screwed.
Oh, twist. Okay. Now.
This is fun.
This is really dumb. Okay. So.
My favorite.
Let's talk about wheels.
Yeah.
Let's talk about the invention of the wheel. So. Before wheels, there is evidence that we used rollers for moving large, heavy objects. And that's literally like putting a log underneath something or a bunch of logs and then rolling it over the logs. But obviously, this isn't as convenient as a wheel because once you roll past the farthest forward log, you got to get the back log and move it back in front of the front log and then, repeat over and over and over again.
Is that where the phrase backlog comes from?
Probably not.
I was about to have my mind blown.
It sounds like it's plausible, but I'm going to go with no. Anyway.
I don't know. Why not? Don't sell yourself short, Julian.
It's probably from keeping a log of entries of things you need to do, and then the farther back in your log you have to go. That's if I had to guess. Shooting from the hip here. But anyway. Rollers, though, predate the wheel, but they're not the same thing. We're not really going to count those. The first wheel, though, ever. Any guesses what it was used for?
The first wheel ever.
Or at least the oldest wheel we have discovered to date.
to be cheese, to be a wheel of cheese that we rolled.
To exist as food.
Yeah.
To make transporting
food.
Fatty, delicious cheese easier.
Yeah, we were nomadic.
Going back to the mammals needing a lot of calories thing that we stated earlier.
Back to the milk, baby.
If there were ancient cheese wheels, I don't know if we will have the ability to discover them. They don't hold up well to like many thousands of years of time. So
I don't know. I've had a Parmesan that might disagree. Okay, so to would it be to transport bricks, materials to build things, or was it earlier than that?
I'll give you a hint. It wasn't used for transportation at all.
Was it used for fun? Please tell me it was a toy.
Possibly fun as a hobby, more likely used for creating something that was later sold. The oldest wheel that we have discovered to date is from about 6,000 years ago in Mesopotamia, specifically in the Sumerian city of Ur, and it was a pottery wheel.
Oh, wow. Wow.
Yeah.
Seriously?
Yeah. Yes. So the first time we see like a wheel and axle, right? Like something that it can rotate around or be bolted to, and then the axle turns with it. But whatever, like set up to spin freely. The oldest thing we found was for pottery.
Huh.
Yeah.
Cool.
And again, that's 6,000 years ago.
That's quite recent.
So
that's very recent.
Yeah. And furthermore, the thing about using a wheel for transportation, like on a wagon, is that anthropologists think you basically have to slap it all together at once, right? There's no like incremental inventions where you get a cart that I drag in the dirt and then like a cart with one wheel. And no. You pretty much have to go right away to like the cart with the four wheels being pulled by people or beasts of burden or something. Like it points to the likelihood that there was a singular inventor, because it was a machine that had no predecessors really directly.
Wow.
Right?
Yeah, that makes sense.
Yeah. So the first wagon with wheels dates to about 5,400 years ago. So about 600 years after this pottery wheel that we've discovered. We found two wagons with wheels from about this time period, and they're either in like the North Caucasus of Russia or a bog in Slovenia. And the name of the bog is totally unpronounceable. It's got like two J's after other consonants, so I'm not even going to try. But it's kind of hard to pin down exactly where it came from, because once the wagon was invented, it just went everywhere. And I mean the invention like spread, because other people saw it and they're like, that's a good freaking idea. And then, like it makes it, once you see it, you're like, oh, of course we should be we should get on the bandwagon here.
Is that where the phrase?
No,
okay.
It's not.
Okay.
No.
That one, easier to believe.
From a bunch of people inventing wagons quickly. Wow, we've got a band of wagons.
I don't know.
No.
We have Axl Rose, and I'm sure there's a connection.
No, the phrase "get on the bandwagon" did not come from the rapid proliferation of wagons. I can tell you that for certain, because English didn't exist and wouldn't exist for many thousands of years. So,
but I bet we had bands. Okay, carry on.
Okay, I can't do this with you. Okay, so so the wagon just spreads around like wildfire. The articles I found talking about it were like, it went viral, and I'm like, that's very, very silly of you to use modern tech analogies for these ancient things. But anyway,
and back then they were like, everybody died? No,
so,
different viral.
It's terrifying. No, not the bubonic plague. It's fine this time. So we talked a lot in your segment about evolution, and thank you for doing a lot of the heavy lifting for me, because let's contrast this invention of the wagon with how evolution works, right? This invention, and humans and engineers, right, are capable of just envisioning something and then just making it happen all at once, right? It doesn't need to necessarily stem from anything that came before. Evolution, though, it only builds on what came before. Right? It's a tinker. It's a slow process of like tweaks and small alterations and little changes over many, 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 many generations until eventually you get something entirely new and different. You get speciation, which is partly why that ancient question of which came first, the chicken or the egg, is so frustrating, because it presumes that there was like the first chicken.
Right.
And it's like, there wasn't. Like, you can look at chickens today, Hillary, and be like, that's a chicken. And you can look at, like, chicken ancestors from several hundreds of thousands to millions of years ago and be like, that's definitely not a chicken.
That's a dinosaur.
And somewhere in between is the transition point, and there's no definite cutoff of now that's a chicken. Before it was a dinosaur, now it's no. Because it's all slow, gradual changes, it's hard to say when the first chicken was, which is why the default kind of smart-ass answer is like, well, the eggs, because eggs have been around for millions of years. I know that's not what they're asking.
Wow.
But yes.
You have an answer to that question.
Yeah.
Wow.
I mean, if you want to count, dinosaur eggs, which absolutely, then sure. Then the question, I think, really is, okay, if you could point to something as the first chicken, do you call the egg that it hatched from a chicken egg because it's got a chicken in it?
Wow.
Or do you not call it that because it wasn't laid by a chicken?
That is so frustrating. It's sort of like saying a line is made up of an infinitesimal amount of dots.
Yeah,
right?
An infinite series of points, which it is, right? That's evolution for you. It's a continuum.
Right. And it's, but one of those dots has to be a chicken.
One of those, yes, exactly. One of those dots on your line is at point x1, y equals 2. There's also an infinite number right next to it that are very, very close. Anyway, okay.
So frustrating to be alive.
Nuance. I hate it.
But we love it. We're theater people too, so we love it too.
So, because everything has to build off what came before it, right? A wheel, getting an animal with a wheel is a real problem because you need not wheels preceding that until you eventually get a wheel. And if an animal were to evolve things that weren't usable as wheels, kind of like wheels, it'd probably be terrible for that animal. It would probably not be advantageous. And that's ignoring the biological problems of, okay, a wheel has to be able to spin freely. That's the big advantage of a wheel. Mm-hmm. How do you make a biological part of an organism that grows from cells and has to be connected to circulatory systems to get oxygen and nutrients, but then can spin freely?
Mm-hmm. Right.
How do you do it? Okay, can't really do that. But also, it's just there's no structures that would precede that would be beneficial until you get a wheel, right? So it's just not going to happen. I think it's really interesting going back to our lizard, right? If you've ever watched a lizard run, they look really goofy because they do this undulating side-to-side motion. Yeah, they're not like us where they, or dogs where it's one leg in front of the other. They've got to keep like bending themselves side to side to put a foot forward. And that's because they're more closely related to fish that our tetrapod ancestors came out of the ocean from. And fish use that lateral side-to-side motion to swim. Well, when you adapt it for land, it looks really silly. It works well enough. Oh, it's not like the most ideal, but like when an organism's evolving, it's got to work with what it's got. Yeah. So, yeah.
Okay.
And it's also why, as you so kindly alluded to earlier, there's a lot of things that result from this that when observed on their own, you're like, why would anybody intentionally make it like this? Mm-hmm. It doesn't make any sense, right? Like these nerves getting stretched out, because at one point they made more sense because they were just going to the gills, but then when they get stretched out, you get complications as a result. Mm-hmm. So a great example of that too of things slowly building is our eyes, right? Like some people who don't believe in evolution point to eyes and they go, oh, they're so complex. They must be basically like the wagon and wheels, like they must have come together all at once. And that's not the case at all. If you have like single cells that are sensitive to light, that's still useful for some organisms to know, like when it's nighttime or daytime, right? And there's a series of steps where, if these cells just start forming a little cup shape, now they can distinguish movement in their environment better. And then if you just put like a clear little lens over them and start puffing up the lens to bend light, oh my gosh, you can resolve images. It's like a very logical series of steps where they're beneficial all along the way, even if it's not a fully formed eye yet. Mm-hmm. So yeah, it's not an irreducible complexity, as they might say. And we still see animals with these non-eye, like pre-eyes, right? Like flatworms just have the little cup eye, proto-eye thing.
Yeah, it's like a use case. It's what works best for that particular organism too.
Yeah, and if it works, right? And that's the thing is a lot of people also don't understand like why there are living fossils, right? Like why this animal hasn't evolved for so long, and it doesn't need to. Alligators are perfect murder machines. Yeah. They're just like, they're fantastically good at what they do.
And that's the name of your prog rock band.
Fantastical Murder Machines.
Yes. I love your work. I would get on your bandwagon. I did it.
It's like an electric chair on a rainbow is like the album art.
Yeah, I would buy that record.
Trace Dominguez and the Fantastical Murder Machines. He's not in the band, but we named it that to be confusing. Okay, so for that reason, right, we don't see animals having evolved wheels because there's no intermediate steps that really make sense. But then also, as Jade alluded to, what if wheels kind of suck?
What?
Yeah.
What?
Like, I know they're great and they, like, changed society and civilization and everything, but I also think that there's a unnamed invention that does not get credit, that, like, the wheel is taking all its success.
Oh?
And you know what I'm thinking of?
Are you thinking of fire and you're gonna have to change your answer?
No, it's not fire again.
Okay, what is it?
Roads.
Oh, dang, Julian.
I'm just saying, like, the wheel's so great, but the wheel would be nowhere, literally, without roads. The wheel is Steve Jobs and roads are Steve Wozniak.
Wow.
To make a tech analogy for an ancient piece of machinery.
Gauntlet thrown onto a road.
Yeah,
Wow.
Take it, wheel. But
Okay.
no, think about it, right? Just like Jade says, if you're in an undeveloped area, right? Like if you're just out in the woods and there's rocks and tree roots and you don't have legs, you have only wheels,
Bummer.
you're going to have a bad time.
Yeah.
It's not going to be easy to navigate your environment.
No, your knees are gonna hurt so much.
By the way, do you know where the first roads came from?
I was just gonna ask you, so which came first, the road or the wheel? Where did the first roads come from?
Yeah, I literally have that joke in
Oh,
my
no!
script. Thank you for
Sorry.
teeing that up.
No.
Yes, which came first, the road or the wheel? Roads.
Okay.
Wheels, 5,400 years ago. Roads, 6,000 years ago. You want to guess where?
Is it the same areas that the wheels?
It's the same place. It's from Mesopotamia, specifically the ancient city of Ur. That place was a techno cutting edge paradise.
Man, I wonder what it was like to live there in such a golden
It
age.
must have been insane. They're like, oh man, we are like the movers and shakers here. Literally, we've got roads, we've got pottery wheels. The rest of the ancient world looks upon us and trembles.
Yeah.
They're like, I'm just imagining this being ancient Silicon Valley, basically, where they're like, we're gonna shake up everything.
Yeah.
You know what we got cooking up? How we're gonna disrupt the pottery industry? Boom. How are we gonna get it places? Well, wouldn't it be nice if the roads were if the ground was smooth so you didn't break all your pots if you tripped and fell? Boom. Roads.
Yeah. They're in their little ancient hoodies doing ancient ping pong in their ancient offices that have ancient free smoothies. And they're like,
And they're like, damn, if only somebody would invent the number 0 soon, we could keep track
Yeah.
of our sales more easily.
maybe we could make housing less affordable then. Yeah.
We could add more zeros onto the end of all the prices.
I wish I lived in a time with rampant inventions and no money. I would love that. Can we do that, please? I don't know if there was money back then. Was there money back then? I hope not.
There had to. I'm sure there was. Anyway.
Fine. There has to be one downside.
Some sort of economy. Maybe not money, but like definitely a trade and barter system.
I would trade pottery for a wagon. No problem. I'm very good at
Probably
pottery.
need yeah.
Yeah. I can build a wagon. Sure.
Yeah, why not?
Why not?
I've seen the pottery wheel. I now know how to build a wagon.
That's right. See?
I'm going to take your invention.
And that's called
Can you imagine
upskilling, skill sharing. See, that's what we need.
ancient patent claims though, where the potter's like, "Hey, that's my thing."
And they're like, I think the trademark would disagree. Trademark law says it's a completely different purpose and no one's going to mistake them for the same brand. So check
And
the
they're
USPTO.
like, you know what? I have so much seed funding, I will crush you in lawsuits. Literally, I have so many seeds
Yes.
from investors, so much grain
So much.
in my storehouse.
Is that where the term seed funding comes from?
I mean, almost definitely.
That one I feel pretty confident
Yeah,
about.
that's pretty. It's just like seeds grow into things. Anyway.
No, that seems right.
Yeah, that one's pretty obvious. Okay.
This is cool. Roads, wheels. Wow.
Yeah, roads, wheels. So the point is, the environment needs to be conducive for this adaptation to thrive, right? It's not, an organism changes and then makes the environment work for them. No. Sorry, buddy, but if you adapt something, it could be like an amazing adaptation for a different environment. But if it doesn't work where you live, no, that do not pass your genes on. Do not collect $200. Like, that's
Right.
it.
There's a reason we don't have bird lungs.
Right. We haven't needed them. There's no pressure to get them. But there's also natural selection is one mechanism of evolution. And that is where like the environment basically picks the winners and losers of these random adaptations. There's also sexual selection, right? If this adaptation made you like real attractive to the ladies or the dudes, and even though it might get you killed more often, like you also mate more often, then yeah, you can pass it on that way too. Yeah. But still, with wheels, that didn't happen. Probably also because of those biological factors.
No one had big sexy wheels that everyone was like.
I think if a lizard pulled up with like giant wheel legs and was like, "Hey, baby," like if I were the lady lizard, I'd be like, "That guy's compensating for something."
Vroom vroom.
Vroom. Oh, look at this guy.
Anti-sexual selection.
Yeah.
You lose. Immediately.
Oh no, you've invented birth control for yourself.
That's right. That's what happened. Wheels were just, they were like, not buying it.
Yeah, that's it. Yeah, Jade, that's the reason. Now, Jade did allude to the fact that there are some animals that still use wheel-like adaptations in order to roll down hills and stuff. Oh. There is, for example, the golden wheel spider. It lives in some sand dunes. It hides under the sand, but there's a wasp that preys on it, and this wasp can excavate the sand. And so when this spider is discovered, it takes off running down the dune, but once it's got enough speed, it rolls onto its side, it curls its little legs up into a rough wheel shape, and it rolls down the hill a little bit. And it puts more distance between it and its predator, and if the predator keeps up, it makes them harder to attack.
Interesting.
Because they're like a little whirling dervish.
Yeah.
And that's actually, there's a few other bugs, insects, arachnids that do this. There is the larva of a specific tiger beetle will also do this. This beetle lives on the beach where it's really windy. So the larva is like a little worm-shaped thing. It'll fling itself into the air to catch a breeze, then tuck into a little wheel. And when it lands, it rolls, and it can get going several meters per second, and it can go so fast it can go uphill.
What?
Actually. Yeah.
Okay, that's cool.
It is pretty cool, right? But it's not like their bodies have a separate wheel that can rotate freely. They turn themselves into a wheel, because again, they're working with what has come before. And then that's the best they got.
What's the difference then between a wheel and a ball in that situation?
That's a good question. I would say a wheel. Well, are we talking like on a wagon in general, or just like a wheel?
Well, I don't know, because I guess the definition of a wheel versus like a pill bug can curl itself into a ball as well. Right. But it's more of a ball.
But so it's like spherical, whereas a wheel's got to be just like a slice of ball, basically.
All right.
Right?
Yeah, okay.
Yeah. But more importantly, compared to our inventions of the wheel as we think of them, these creatures don't have an axle attaching them to something else. Yeah. And the axle's spinning, but the other thing isn't. That sort of thing.
That's what I was thinking about, is the axle. But again, to the cheese point, a wheel of cheese doesn't have an axle. So I see. All right.
It's true.
Okay.
It's true.
Back on track.
Well, I mean, it'd be easy to add one, just like a hammer and a spike, I feel like. Yeah. Bring out the cheese wagon. Okay.
We should be in Mesopotamia inventing things for the rest of our lives. We were born into the wrong era.
Kind of. I want to see a Silicon Valley Mesopotamia, a Tigris and Euphrates Valley.
Like, I'm gonna try to write that. I think
it'd be a good pilot, honestly.
Oh, you want a whole series?
Let's do.
I was gonna do a sketch, but
okay.
No, let's see where this goes. Let's Succession style.
Why not?
Yeah.
I think there's a lot we could plumb there. Oh, they could invent plumbing. Okay.
Oh my God, you're right. This has legs.
But then not let anybody else use it.
You gotta pay a quarter.
Or like make it a subscription model.
This is how money starts. Yeah.
Okay. So with all these things we've teed up about evolution, though, like your environment has to be conducive to the adaptation. It has to be like something that emerges from previous generations' adaptations and what was available to them. I think there's a question here that nobody's asking because it's not as obvious, but I think it's a good one.
Go on.
And that is, why don't we see any organisms with propellers? I mean, think about it. This is my thinking, right? Life started in the ocean, right? So early days of life, you're surrounded by water. Fish, the way they swim by moving laterally, undulating, works great, but so does a propeller, which if you think about it is kind of like a wheel, just with special kind of spokes to push water backwards, and so to propel a craft or something forwards, right?
Yeah.
But it works, a propeller and the way fish swim both work, unlike walking and trying to use wheels instead in an undeveloped environment where that doesn't work. A propeller could work. So why don't we see organisms with propellers?
And we don't.
Sophie?
Why? Because a propeller does require a wheel and axle.
Kind of. I'm being very tricky with how I ask this question.
Is it a trick question because we do see animals with propellers?
Why don't we see them?
Because they're
too small.
Because we just can't see them.
Because they're microscopic, but they do, in fact, exist. And I'm talking about bacteria and archaea.
I was thinking, I was like trying to rack my brain back from biology classes. Wait a minute, I'm getting a vague sense memory of something that does this. For the listeners.
For listeners of this audio podcast, Sophie just waved her arms around wildly with no semblance of coordination.
Because I do not have a propeller. I did not evolve that way, but I had the idea of it. Yes.
So you're going to claim intellectual property.
Yeah, those bacteria need to pay up.
Hey. Okay, so yeah, many species of bacteria and other single-celled organisms, archaea, they're technically a different whole family, but they're also ancient single-celled organisms. They have flagella. And they're different structures, which is part of what makes them different groups, is that even though they both have flagella that rotate like a propeller would, they're assembled differently.
Of course.
Now,
okay. Yeah.
we also have some cells with flagella, specifically, sperm cells for mammals and vertebrates, right? They have flagella so they can swim, but the flagella of eukaryotes work totally different from these bacteria and archaea. Their tails are more whip-like and they go back and forth from side to side, which, by the way, that's what flagella means. It's the Latin word for whip, which makes the flagella of bacteria and archaea kind of a misnomer because they genuinely do spin around like a rotating motor. And it's this really cool, complex, very large, like cellular mechanism, like piece of machinery that works. Basically, it looks kind of like an electric motor. It's nestled in the two layers of cell membranes that these bacteria have, and it's got some stationary parts that protons pump through, and as they move through it, they can spin the rotary part of this motor, and they can actually spin it 100,000 times a second.
What?
Yeah, and then they can stop in the span of a quarter turn and then go the other way.
What?
And spin backwards.
Wow.
Yeah.
Wow.
They're really incredible pieces of microscopic machinery.
Huh.
And so they drive this long whip-like tail that when it spins, it kind of looks like a little helix, a little spiral, and that moves the fluid that they're in, and they can swim comparatively really, really fast for their size.
So is the movement stemming from a base then that is like a wheel and axle, if that's the motor that you're saying?
Yep.
It's coming from the base, not from somewhere within the actual long tube, if you will.
It's coming from that base that's anchored into those cell membrane. Yeah, and then the whip-like structure is just free to spin around for the ride, but there's nothing in there driving it. Unlike, like I said, the sperm cells, there are proteins in there that flex back and forth.
Okay.
But that's not how the prokaryotes do it.
Wow. So I was thinking about a propeller as something with more horizontal pieces that are sticking out of a motor horizontally, but that was my own just sort of modern immediate thought of a propeller. If I took a belt or a rope and just started swinging it around over my head, that's a propeller. Technically?
I mean, if it's propelling you through fluid, I think, technically we'd call it that.
So if it isn't functional, it's just...
No, then you're just a crazy, dangerous person with a belt that you're waving around above your head.
Oh, so I have to use it for good, not evil. Otherwise,
yes,
it doesn't count.
Exactly.
Okay.
That's what we're getting at.
Got it.
Yeah.
Okay, understood.
Precisely. Okay, so What's the difference between a propeller and a whip? Whether it's used for good or evil. Okay.
That's science.
I don't think that's the exact definition, but sure.
Okay, got it.
But this is another example that, people have pointed to as, oh, this is another irreducible complexity. Look at the flagella of bacteria. It must have been created all at once. And the thing is, no, it's really similar to other structures that bacteria use to inject proteins into their environment. Basically, these kind of syringe-like little structures that they have that let them affect their environment by squirting stuff into it. And when we look at the structures of the flagella and these injector proteins, they look really, really similar. They probably came from a common cause. So it's an example, likely, of evolution taking a structure that was meant for one thing that slowly became more adapted to that, and then changing its purpose through some other mutation to do something different that was advantageous, which is moving around. It's obviously being able to control where you go if you're any organism is probably nice to have. Unless you're a jellyfish, and then you just don't care. And you just go wherever.
Because you're the king of the world.
Yeah, nobody's coming near you.
No.
Nobody's touching you. You're scary and dangerous.
Not a single predator of the jellyfish. They're apex predators.
But
that's not true. That's not true, listeners. Right.
Jellyfish? No, they're not apex predators.
Just wanted to clarify that was a joke.
Sea turtles, leatherback sea turtles. Yeah, eat jellyfish. That said, though, they're still freaking scary. Okay,
yeah.
I wouldn't deal with them. No. Okay, so fish, though, or larger organisms don't have propellers for those same reasons we talked about, right? How would you grow this and then detach it, and how would you still keep this, these biological tissues alive or stuff like that? I don't know. But yeah, bacteria, archaea, a lot of them, not all of them, but a lot of them have basically propellers, and it's for the same reason that we have wheels. It just was a really efficient way of getting around their environment. And I think that's cool. So, Jade, I hope that answers your question. Wheels, biologically impossible to make. There's no intermediate structures between what exists and wheels that would let them repurpose them. And their environment would not allow it anyway. But at least we can still get around on good old-fashioned feet.
Hey, Julian.
Yeah.
How many simple machines are in our body?
I don't know. I haven't eaten many Hot Wheels lately, so...
So for you, big fat goose egg.
Like 3.
Oh.
I think there's 3 floating around in there.
Well, right. But is it a simple machine if it's an evolutionary structure versus something that we built as a tool? But the idea of an inclined plane, a lever, a screw.
Okay. I mean,
what do you think?
I feel like teeth are like an inclined plane. Ooh. Arms and legs are definitely levers. Would you say that our ball and socket joints are like wheels?
Well, I was wondering about that. I think they're close, but not exactly.
Similar, but no. Okay, so what's the answer?
I think that the wheel is the only one that doesn't exist in our body.
That would make sense to me.
Because we've got pulleys. Yeah. Our muscles are pulleys.
Right.
We've got wedges. Our teeth are wedges, which, to your point, are just 2 inclined planes in a triangle.
Just back to back, yep.
I'm not sure about screws, except I think at the molecular level, I think we do have some. I know we have screw-shaped things like DNA, but that's not used as a tool to make work easier.
I don't know. I feel like if we're talking about certain animals like ducks or pigs, they have screw-shaped genitals.
True. There we go. Great. It's a tool.
Yep.
Okay.
Sure.
I think so. I think that's interesting.
What are the other simple machines?
We've got, what did we cover? A wheel and axle, which that's the one we're saying no. Inclined plane, lever, pulley, wedge, screw. 6.
Okay. Yeah, so pretty much all of them but wheels. And screws unless you're a pig or a duck.
Yeah. If the definition of a simple machine is to make it easier to use less force to do work, increasing distance. To give you a mechanical advantage. Right. I think we'll need to look more into ducks. Well, I have more homework.
I know you're a guest, but that's always the conclusion that Trace and I come to.
Tune in next time when you never cover it, ever.
It'll come up. Just wait. Well, Sophie, thank you so much for coming in today. It was a pleasure having you filling in for Trace.
I hope I did a good Trace impression throughout this entire episode. Thank you so much for having me.
Oh, couldn't tell the difference the entire time.
We look alike, too, which helps. You can't tell on podcast, but
You and Trace.
we look the same.
Literally identical. Sophie, if people want to find you, where can they do that?
Oh, Instagram's a great place. Science with Sophie on Instagram. We are going to be announcing more stuff about a new project very soon, so now's a great time to tune in.
Is it duck related?
It might be now. It's electric car related, but you never know.
Which, if you relate that to duck penises, I will give you $5 whole. If you find a way.
Mesopotamia dollar? I'm in.
Oh, it'd be worth a lot if you invested it back then.
Yeah.
You know.
I'm in. Challenge
I've got this new investment. It's called coin. Just coin.
Just coin.
Just coin.
They're like, no.
Oh, no.
That'll never work.
We've printed they have no inherent value. What do you mean coin?
What do you mean coin?
Well, good luck. I'm going to hold on to this coin. I made some coin with the face of my dog that I also just invented.
This one inventor, she was
This one,
prolific.
on a tear.
I think it was Mesopotamia. It was actually a woman who was just inventing all these things, and they just named the town after her, and that got lost in the annals of time.
Probably.
Yeah.
Must be.
Yeah.
Okay.
Yeah, she was great. I'm going to be her for Halloween this year.
We're going to work on this. It makes no sense to anybody.
No.
Who are you, Sophie? I'm the woman who invented pottery wheels and roads and Bitcoin.
And dogs.
What? And dogs. Thanks for listening to this episode of That's Absurd, Please Elaborate. The show was created, written, and produced by me, Julian Huguet, and of course, Trace, who's not here. It was produced and edited by the wonderful, wonderfully talented, multi-hyphenated inventor, Kyle Sisk. Special thanks to listeners who submitted questions featured in this episode, Hillary and Jade. If you would like to submit a question, look for the form in our show notes, or you can email us at hello@that'sabsurdshow.com, or you can visit our website, that'sabsurdshow.com/ask. You can even call and leave a voicemail, 302-TAPE-SHOW, SHO. If you've got the time and inclination, you can leave a review wherever you're listening right now. Hearts, stars, words, and of course, keep sending in those questions. They make the show possible. They make us laugh. We love them. We get a big kick out of them. Keep them coming. Finally, special thanks to those listening on Nebula. Nebula listeners get access to ad-free versions of episodes, and they can support us and other independent creators. To join Nebula, visit go.nebula.tv/that'sabsurdshow. And Sophie, what do we always say at the end of every episode?
Duck.
Duck. We need more research on duck dicks.
Please.
The people demand it.
We must know.
We must know about duck dicks. Woo!
Everybody's wondering about ducks. Woo! Ducks, look behind you. There's a duck out to find you.
Oh no. No, stop. It gets worse. It gets so much worse.